Well, last time we discussed about particle on a ring. Okay, particle on a ring. That is two-dimensional rotational motion. Ring means it is a circle. So two-dimensional rotational motion. Okay, we discussed about this. Actually, this is not included in your syllabus. But in order to discuss about free axis rigid rotor, so we have to discuss about particle on a ring. That's why I have discussed. Okay. So we discussed about particle on a ring, then particle on a sphere. This is 3 dimension. We discussed about this. Okay. And we solve the Schrödinger equation for the particle which is moving on the surface of a sphere. Okay, and we obtained wave function. We obtained wave function. We obtained wave function and energy. Wave function and energy. Okay. Wave function depends on two quantum numbers, L, M, but the energy depends on one quantum number, L. And values of L may be like this, M may be like this. Okay, we have already seen this. So, using these results, we also discussed what degeneracy is. Okay, say for example, when L is 0, energy is 0. Here energy, this is rotational energy. So when L is 0, rotational energy is 0. And when L is 0, M is also 0. So we have one wave function, and that wave function is a constant. That wave function is constant. Why we call it constant? Because there is no variable theta and phi. There is no variable theta and phi, so the wave function is constant. Okay, so one energy level when L equal to 0, one energy level, and we have one state, that is one function. But when L equal to 1, okay, energy is this much. Again, when L equal to 1, M may be 0 plus minus 1. And accordingly, we will get three wave functions. That means 3 states. So these energy levels, okay. So let me show here. Actually, we discuss about these things. Say when energy is E naught, that is 0, there is one wave function, psi 0, 0, 0. And when energy is E1, this energy is E1, we have three wave functions, psi 1, 1, psi 1, 0, psi 1 minus 1, psi 1, 1, psi 1, 0, psi 1 minus 1. So this particular energy level is degenerate. And this level is threefold degenerate. So we discussed about this. Okay. So using these results, we can discuss what degeneracy is. Okay. Next, we discuss about free axis rigid rotor. And we have seen that the values of wave function and energy are exactly the same as that particle in one-dimensional box. So wave function is as before. What is the value of the wave function? 2L plus 1. Now this is free axis rigid rotator. Free axis rigid rotator. Okay. Rigid rotator means bond, this distance is constant, does not change. Free axis means axis may be taken like this, axis may be taken like this, any direction. Axis may be taken in any direction. So it is three-dimensional motion. Now, the value of the wave function and energy is value of the wave function and energy of free axis rigid rotator. Free axis rigid rotator is are exactly the same as that of particle on a sphere. Okay, P L M cos theta e to the power I m phi. So this is the wave function for particle on a sphere. Now same wave function is for free axis rigid rotator. Same wave function. Okay. Similarly, energy, same energy equation. We have already discussed about this. Same energy. Okay. Same expression for energy. Again, wave function depends on two quantum numbers. So energy depends on one quantum number. And same is L equal to 0, 1, 2, 3, etc. M equal to 0, plus minus 1, plus minus 2, etc. Same. Exactly same. Results are exactly same as that for particle on a sphere. Okay. So, here you remember the wave function for particle on a sphere or rigid rotator. I repeat, the wave function for particle on a sphere or rigid rotator is called spherical harmonics. Spherical harmonics. This wave function is called spherical harmonics. Okay. So today we'll discuss about hydrogen atom. Okay, we are going to discuss about hydrogen atom. Okay, hydrogen atom or hydrogen-like atom. Hydrogen atom or hydrogen-like atom. We are going to discuss about this. Okay, so let us see the system. Say this is the okay, this is the hydrogen-like atom, say, and this is the nucleus. This is the nucleus. Okay, this is the nucleus. And this is the electron. Say suppose this is the electron. Charge of electron is minus E and charge of nucleus is plus JD. You know Z is the atomic number. Okay, for hydrogen atom Z is 1. Okay, you know this. Now say this is this distance. Okay, this distance is r. Okay, this distance is r. This is the radial distance of the electron from the nucleus. Okay, so this is the radial distance. Now this is hydrogen atom or hydrogen-like atom. Now, there are two particles, nucleus and electron. There are two particles, nucleus and electron. Now, for the complete system, okay, for the atom, for the atom, say Schrodinger equation, let us write it like this: Ht psi t equal to Et psi t. This is the equation number 1. For the complete atom means nucleus and electron. So for this atom, this Schrodinger equation is this. Now here Ht, Hamiltonian operator. What is Ht? It will contain, what does Hamiltonian contain? It contains operator for kinetic energy plus operator for potential energy. Okay. But there are two particles, nucleus and electron. Suppose mass of the nucleus is capital M, mass of the electron is small m, suppose this. Okay. So there is kinetic energy term for the nucleus, then kinetic energy term for the electron, then potential energy term V. Here potential energy, what is the expression for potential energy here? Now potential energy is due to the electron nucleus attraction. Here potential energy is due to electron nucleus attraction. So what is the potential energy? Definitely you know this 1 by 4 pi epsilon naught Z E square by R minus. This is the potential energy for this system. Okay. Now here you see, as R decreases, potential energy increases. Okay, attraction increases. As R increases, attraction decreases, potential energy decreases. That means towards the center, any direction towards the center, potential energy is more. As you move away from the nucleus, potential energy decreases. Therefore, it is also called the central field problem. That means potential energy is directed towards the center, that is nucleus. So this is also called central field problem. And you know, there is strong attraction between nucleus and electron. Strong attraction between nucleus and electron. Okay. Now, what is the kinetic energy term? Kinetic energy term is minus h bar square by 2m, say del n square, Laplacian operator. Okay. Then kinetic energy for, this is capital M, mass of the nucleus, electron. Suppose I write it like this. Okay. I may write like this also. Okay. E for electron. I may not write it. Okay. Then potential energy. Say Z E square by 4 pi epsilon naught. So this is the Hamiltonian operator here. Okay. Now, in order to solve equation 1, we have to simplify it. You know this. In order to solve equation 1, we have to simplify it. And how to simplify it? You may think that we can divide the equation into two parts. One part for nucleus, the other part for the electron. You may think like this. Okay? But that is not correct. Why that is not correct? We can divide this equation into two parts only when there is no interaction between the two particles. In that case, this wave function psi t will be a product of two independent wave functions. Okay, I repeat. So I can divide this equation into two parts as one equation for nucleus, the other equation for electron. We can divide it. When we can divide it? We can divide it when they are independent of each other. Nucleus and electron, they are independent of each other. But that is not the case because there is strong attraction between the two. Therefore, we cannot divide this equation into two parts, one for nucleus, the other for electron. We cannot do that. Okay. But we may consider two types of motion here. We consider two types of independent motions. Independent motions. What are those two types of motions? One is motion of the atom as a whole. Motion of the atom as a whole. Okay, that means we are not considering what is there inside or outside. We are not considering that. As if the whole atom is one particle. As if the whole atom is one particle, it is moving in this direction or in this direction or in this direction. Translational motions. This is nothing but translational motion. This is translational motion. Translational motion. Okay, motion of the atom as a whole. Atom to গোটেই এটমটোক আমি এটা বস্তু বুলি ভাবি লৈছোঁ ইয়াৰ ভিতৰত যে নিউক্লিয়াছ ইলেক্ট্ৰন আছে সেইবোৰ আমি কনচিডাৰ কৰা নাই এটা বস্তু এই বস্তুটোৱে ইফালে ইফালে মুভ কৰি আছে দ্যাট ইজ মোশন অফ দি এটম এজ এ হোল সেকেন্ডটো হৈছে কি motion of the electron with respect to the nucleus. Okay, or nucleus also may keep moving. Okay, that is one particle, say electron is moving with respect to the nucleus. Relative motion. This is nothing but relative motion of one particle with respect to the other. Okay, this is not translational motion. This is translational motion, but this is not translational motion. This is relative motion. Okay, so these two types of motions are independent because atom may be here, then also electron is rotating around the nucleus. If the atom comes here, then also electron is rotating around the nucleus. So motion of the position of the atom may change since it is moving, but the relative motion is not affected. Relative motion of the electron is not affected. So these two types of motions are independent. Okay. Now this motion is equivalent to the motion of the center of mass. Motion of the center of mass. Center of mass means, say here center of mass is very close to the nucleus, because nucleus is very heavy. Even hydrogen nucleus is nearly 2,000 times heavier than the electron. Okay, hydrogen nucleus is nearly 2,000 times heavier than the electron. And you know, hydrogen nucleus has only one proton. So you see, but helium nucleus, if you consider helium plus, then this is helium nucleus. Okay, there are 2 protons and 2 neutrons. So this will be much more heavier than the electron. Therefore, center of mass will be very close to the nucleus. Okay, so atom is moving as if the center of mass is moving. And center of mass means 1 point, so it will have coordinate. Let the coordinate of the center of mass be, say, x, y, z. Okay, let the coordinate of the center of mass be this. And what is x? X equal to, say, here coordinate of the nucleus, say x1, y1, z1, and coordinate of the electron is, say, x2, y2, z2. Coordinates axis are here, coordinate axis is here. So coordinate of the nucleus x1, y1, z1, coordinate of the electron x2, y2, z2. So x equal to m x1 plus m x2, and this is m plus m. Similarly, y equal to m y1 plus m y2, m plus m, and similarly z. So we define the coordinate of center of mass as x, y, z, where x equal to this, y equal to this, and z will be similar expression. Okay. So motion of the atom as a whole is equivalent to motion of center of mass. Okay. Now motion of electron, that is relative motion, that is equivalent to, say, motion of a hypothetical particle. Mu. Actually, mu is the reduced mass. Okay, with respect to center of mass. So we consider 2 independent motions. Okay, and this motion is equivalent to motion of center of mass. This motion is equivalent to motion of a hypothetical particle with mass mu with respect to center of mass. Okay, what is mu? Actually, mu is the reduced mass. Okay, and say, what is the coordinate of mu? Mu, that is, say, x, y, z. Okay, what is x? x2 minus x1, y2 minus y1, and z equal to z2 minus z1. So coordinate is this. Okay, so for these two types of motions, we are considering two as if two particles, and these two motions are independent, so they are also independent. So they are also independent. Okay, they are also independent. Now this equation, okay, this equation 1, we can write it like this. This equation we can write it like this, say minus here h equal to this, okay, 2m h, this is 2m, but here we have to write center of mass, so we have to write 2m plus m, center of mass, we have to write like this, okay. And center of mass, let me represent it as q, center of mass, okay, let me represent it like this. Then minus h bar square by 2 mu, and let me represent it like p square, okay, p square. Then we have potential energy. What is potential energy? Potential energy equal to z e square 4 pi epsilon naught r, oh r, 4 pi epsilon naught r, okay. Then h equal to this, okay. Then we have psi t, that is equal to e t psi t, e t psi t, okay. So now since these two wave functions, okay, since these two wave functions, these two particles are independent, okay. Say for this particle, say wave function is for this particle, say wave function is psi q, okay, psi q, or I can write it as phi. For this center of mass, wave function say phi, and for this wave function is say psi. Mu, for mu wave function is say psi, okay. Now they are independent, so psi t we can write it as phi into psi, okay, because now they are independent, so this psi t can be written like this. So this is the equation number 2. So from 2 we can write it like this. So from here, so if we write like this, del 2 psi t, that will be equal to psi into del 2 q phi, because we are differentiating with respect to this. And what is this? What is, okay, what is del q square, that is equal to del 2 del capital X square plus del 2 del capital Y square plus del 2 del capital Z square, X, Y, Z, this center of mass. So this means we are differentiating with respect to capital X, capital Y, capital Z. And since this is independent of it, mu, this is independent of mu, so this is constant, so we get this. Similarly, say del p square psi t, del p square psi t, this will be equal to phi into del p square psi, it will be this. Okay, so we can from 2 we can write minus h bar square by 2m plus m. Okay, this into this into this. So for this I can write this psi del q square phi, then minus h bar square by 2 mu phi phi del del p square k square psi. Okay, then minus z e square 4 pi epsilon naught r psi phi. Okay, psi t equal to this, so this equal to et psi phi. Now dividing both sides by this, what we get? We get minus 1 by phi h bar square by 2m plus m. This is del q square phi minus 1 by psi h bar square by 2 mu del p square psi minus z e square 4 pi epsilon naught r equal to et, because we are dividing both sides by this. Okay, we get this. or we can write like this, or minus 1 by phi h bar square by 2m plus m del q square phi. This is equal to et plus z e square 4 pi epsilon naught r plus 1 by psi h bar square 2 mu del p square psi. We can write like this. Okay, we can write like this. Now here you see this portion is independent of small x, small y, small z. This portion is independent of small x, small y, small z. This portion is independent of capital X, capital Y, capital Z. Okay, but they are equal. So what we get? So this is independent of small x, small y, small z. This is independent of capital X, capital Y, capital Z. But they are equal. Since they are equal, so we can write that minus 1 by phi h bar square 2m plus m del q square phi equal to et plus z e square epsilon naught r plus 1 by psi h bar square by 2 mu del p square psi. So that is equal to some constant, say w. That is constant. Okay, constant. So we are getting two equations. One equation is this 1 by phi h bar square 2m plus m del q square phi equal to w. One equation is this. The other equation, this equation is say number 3. The other equation is this 1 by psi h bar square by 2 mu del p square psi del p square psi. So this is a minus z square 4 pi epsilon naught r. I am taking this to this side, this to this side. So this minus, okay. Then we bring this side, this, okay. And this is say E. Let me write it E. So this equation is 4. This equation is 4. Now we have already said that this is the motion of the center of mass, and this is nothing but translational motion. Translational motion. That means center of mass is moving this way or this way or this way, any direction, moving in a straight line, moving along a straight line. So this is nothing but translational motion. And we have already discussed translational motion of a particle in one-dimensional box and particle in three-dimensional box. So this will give us no new information. That is translational motion only. Okay. But this is the relative motion of mu with respect to center of mass. So this will give us some new information. Okay, this will give us some new information. So we will consider this equation. Okay, we will consider this equation. Now here in equation 3 you see what is the mass? M plus m. Okay, m plus m. But we have already said that mass of electron is very, very small compared to the mass of nucleus. Mass of electron is very, very small compared to the mass of nucleus. So we can write that this is approximately equal to capital M. Capital M. Okay. So if we neglect this, so this will be the equation for the nucleus. This will be the equation for the nucleus. Similarly, here what is mu? Let me see. Let me write. What is mu? Mu is reduced mass. Okay. What is reduced mass? 1 by mu equal to 1 by m plus 1 by small m. Okay. That means it will be m into m divided by m plus m. Okay. Reduced mass. And since we have already said that m is very small, so this is equal to m. Okay, so m cancel. So what we get? This is equal to m. That means mu is essentially the electron. We can say that mu is essentially electron. So if we write equation 4, okay, we can write equation 4 like this. Okay, so I can multiply by psi. I can multiply both sides by psi. Okay, if we multiply by psi, this psi will cancel. There will be psi. There will be psi. Okay. Okay. So let me write that. So minus h bar square by mu. In place of mu, I will write m, because we have already shown. Okay. Then let me write it as I have written del p. Okay. I wrote del p square. Let me write it as del square. For convenience, nothing else. For convenience, nothing else, psi. Okay? Then minus z e square 4 pi epsilon naught r into psi, and that is equal to E psi. So we are getting this equation. We are getting this equation. This is equation 5. Equation 5. Okay. This is equation 5. So now we have to solve equation 5. Okay. So we are not going to consider the equation for the center of mass. Once again, we are not going to consider the equation for the center of mass because that represents translational motion only. But this will give us new information, so we will consider this. Now this is the equation for the electron, because here m is the mass of the electron. This is the equation for the electron. So this represents motion of the electron with respect to the nucleus. This will represent motion of the electron with respect to the nucleus. Okay. So now solution of equation, solution of equation 5. Now here I can write the equation like this. Okay, I can write what is del square. Del square equal to del 2 del x square plus del 2 del y square plus del 2 del z square. Okay, psi minus z e square by 4 pi epsilon naught r psi equal to E psi. This. Okay. So this equation is this. Let me call this 5. This equation is this. Now, in order to solve this equation, we transform it into polar coordinates. In order to solve this, we transform it into polar coordinates by using these relations. X equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta. So using these relations, we transform the equation 5 into polar coordinates. Okay. So in polar coordinates, this equation will have this form in polar coordinates. In polar coordinates, equation 5 will have the form so minus h bar square by 2m. Do you remember this? R square, okay, del r into r square del psi del r plus 1 by r square sine theta del theta sine theta del psi del theta plus 1 by r square sine square theta del 2 psi del phi square. For this we have this. So you have to remember this. For this we have this. Okay. Then minus z e square by 4 pi epsilon naught r psi equal to E psi. So this is the equation. So this equation in polar coordinates will have this form. Okay. For this we have this. Okay. So we are getting this equation. Now you know there are three variables. Here psi is a function of r theta phi. Here psi is a function of x, y, z. So why once we transform into polar coordinates, psi becomes a function of r, theta and phi. Okay. Now in order to solve equation 6, we have to divide the equation into three parts. In order to solve equation 6, we have to divide the equation into three parts. One part will contain r, the second part will contain theta, and the third part will contain phi. Okay, so after all we have to divide this equation into three parts. Okay, now how to do that? How to divide this equation into three parts? For that we first assume as if psi, this psi equal to r t theta u phi, where r this is a function of r and independent of theta and phi. Similarly, t theta is a function of theta and independent of r and phi, and u phi is a function of phi and independent of r and theta. That means in order to divide this equation into three parts, we first express the function as a product of three independent functions. Okay, we first do that. Okay, now say this is the assumption 7. Okay, now here what we have del psi del r. Okay, now from 7 we are differentiating with respect to r. So this will be constant. So what we get? We will get t theta u phi, and we can write dr, or I can write it like this: t u dr by r dr. I can write it like this. Okay, I may not write this portion theta phi r. I may not write this. I can write this. Similarly, we have del psi del theta. So you notice here we have partial differentiation. But here I am not writing partial differentiation because here we are having only one variable, because we are differentiating with respect to r. These are constant. Okay. Similarly, del psi del theta, that also can be written as r u d theta. Similarly, del psi del phi. That also can be written as RT d u d phi. You can write this. Now we can substitute these values. We can substitute these values in 7. We can substitute this value in 6, sorry, in 6. So if we substitute these values in 6, so what we get from 6, what we get? Some, I can do one thing also. I can divide both sides by this. I can divide both sides by this. Okay? If we divide both sides by this, I can divide this. So I'll write by doing that. Okay? I will write by doing this simultaneously. So 1 by r square, 1 by r square. Now here we have del r. So I will not write partial differentiation. I will write simple differentiation. dr. Okay. Then r square, and these are constant. Okay. tu, these are constant. d r dr. Okay, dr. All right. Then 1 by r square sine theta. Once again I will write d theta, not del theta. Okay. Then sine theta, and now what are constants? Ru, dt d theta. Okay, dt d theta. Then plus 1 by r square sine square theta into, I will write, now we have this, so this will be this. So this will be RT d2u d phi square. Then this will be minus 2m by h square, z square 4 pi epsilon naught r rtu psi. Okay, this is z square, so we are dividing by this, 2m by h bar square minus, so minus means it will be plus. Okay, it will be plus. Okay, 2m by h bar square, z square 4 pi epsilon sir, and psi equal to rtu, and this will be equal to minus 2me by h bar square rtu. So we are getting this. Okay, all right. So I am doing two things. First thing, we are replacing this. At the same time, we are dividing both sides by this. Okay, so we will get this. All right. Now dividing both sides by RTU, dividing both sides by RTU. What do we get? So 1 by r square, and that will be equal, this is 1 by r. I can take out tu outside, I can take out tu outside because they are constant. Okay, so I am dividing by rtu, so this d dr d dr r square dr by dr, okay, plus similarly I can take this out, so it will be 1 by t 1 by t 1 by r square sine theta d theta d theta, okay, d theta sine theta dt d theta dt d theta, then plus 1 by r square sine square theta into 1 by u d2u d phi square, okay, d phi square plus 2m by h bar square z square by 4 pi epsilon naught r, this will cancel out, equal to minus 2me by h bar square. So we are getting this. Okay, now what we do, we multiply both sides by r square sine square theta, multiply both sides by r square sine square theta, then what we get, okay, multiplying both sides by r square sine square theta. So what we get, 1 by r square, that is what we get sine square theta into 1 by r d dr r square dr, okay, then what we will have, we will have sine theta by t d theta sine theta dt d theta, okay, then plus 1 by u d2u d phi square, okay, plus 2m by h bar square z square by 4 pi epsilon naught 4 pi epsilon naught, then it will be r sine square theta, and this will be equal to minus 2me by h bar square r square sine square theta, okay. Now I can write like this, sine square theta by r d dr r square dr r dr plus sine theta by t d theta sine theta dt d theta, okay, dt d theta, plus, so this term, okay, this plus this term 2m by h bar square z d square 4 pi epsilon naught r sine square theta, r sine square theta, then this term left this side plus 2me by h bar square r square sine square theta, okay, then this term right hand side, this will be minus 1 by u d2u d phi square, okay. This is the equation number 8. This is equation number 8, okay, equation number 8. So what we have done is that now initially with this term we had r square sine square theta. Initially with this term we had r square sine square theta. Now this term is independent of r square sine square theta. So if you look at this equation, equation 8, if you look at this equation, on the left hand side we have variable r and theta. On the left hand side we have variable r and theta, okay. Left hand side depends on r and theta, but right hand side is independent of r and theta, okay. Right hand side depends on phi, left hand side is independent of phi. So what we can do, so we can write that sine square theta by r d dr, r square dr by r dr plus sine theta by d theta, sine theta dt d theta plus 2m by h bar square z square 4 pi epsilon naught r sine square theta plus 2me by h bar square r square sine square theta minus 1 by u d2 u d phi square. So this is equal to some constant, let me call this m square constant, okay, constant, because left hand side depends on r and theta independent of phi, right hand side depends on phi only independent of r and theta. So this is equal to some constant. So we are getting two equations. One is minus 1 by u d2u d phi square equal to m square. We are getting one equation, say 9. And the other equation is this, sine square theta by r d dr, r square dr plus sine theta by t d theta, sine theta dt d theta, okay, plus 2m by h bar square z square 4 pi epsilon naught r sine square theta plus 2me by h bar square r square sine square theta, okay. So equal to m square. We are getting two equations. Say this is equation 10. We are getting two equations. That means we are getting one equation containing only phi. We are getting one equation containing only phi. Okay. Now we have to divide these two equations. Here we have variables r and theta. We have separated one variable phi. Now we have two variables r and theta. So we have to separate r and theta also. So how can we do that? One thing is that we can divide uh, this equation, because here you see, here with r we have sine square theta. So we can do that. What we can do is that we can divide equation, okay, equation 10 divided by sine square theta. Then what we will have, 1 by r d dr r square dr plus 1 by t sine theta d theta sine theta dt d theta, okay, plus 2m by h bar square z e square 4 pi epsilon naught r, sine square theta cancels, then plus 2me by h bar square, then r square equal to m square by sine square theta. So we are getting this. Okay. Now you see, there is r, no theta, there is theta, no r, there is r, there is theta. So what we can do is that we can write like this: 1 by r d dr, d dr, oh sorry, d dr, okay, d dr, d dr 1 by r d dr r square dr plus 2m h bar square z e square 4 pi epsilon naught r, then 2me h bar square r square, that is equal to m square sine square theta minus 1 by t sine theta d theta sine theta dt d theta. Okay. Now you see, left hand side depends on r independent of theta, right hand side depends on theta independent of r. So this must be equal to some constant beta. So this is equal to some constant beta. Okay. Okay, what I am saying is that this is independent of theta, depends on r. This is independent of r, depends on theta. But since they are equal, so this is equal to some constant, say beta. Okay. So we are getting two equations. One equation is this: 1 by r d dr r square dr plus 2m by h bar square z e square 4 pi epsilon naught into r plus 2me h bar square r square, that is equal to beta, and another equation, so m square by sine square theta minus 1 by t sine theta d theta sine theta dt d theta, that is equal to beta. So we are getting two equations. Okay, we are getting two equations. That means what we have done is that, say this is the equation number 11 and this is equation number 12. Okay, so what we have done is that we have separated the three variables. We have separated the three variables r, theta and phi. Okay, so initially the equation had three variables. Initially the equation had three variables and we have separated the three variables. That means from one equation, equation 6, we are getting three equations. Okay, so from one equation we are getting three equations. Alright, and what are those three equations? Those three equations are, this one is this, where we have only phi, then another is this, where we have only r, and the last one is this, where we have only theta. Okay, that means we have separated the three variables. Okay, now so we can separate, we have already seen the solution of this type of equations in particle on a ring. We have seen this. Okay, so we know the solution. Then we are not going to discuss about the solutions of these three equations separately. Now what we want to do is that we'll just write the results. Say if we solve this equation, what we get? We get the value of u. Okay, if we solve this equation, we will get the value of u, this function. We will get the value of this function. Similarly, if we solve this equation, we will get the value of this function, t theta, t or t theta. If we solve this equation, we will get the value of the function r. At the same time, we will get the value of energy. Okay, I repeat, if we solve this equation, we will get the value of this function u or u phi. Okay, u phi, and we already know what the result will be. This will be 1 by 2 pi whole to the power half e to the power I m phi. We have already seen. Okay, similarly, if we solve this equation, we will get the value of the function t theta. We will get the value of the function t theta. Similarly, if we solve this equation, we will get the value of the function r. At the same time, we will get the value of energy. Okay, now what we are going to do is that we will not discuss about the solutions. How these equations are solved. We are not going to discuss about all these things. we will just write the results. Okay, say solving this equation, we get the value of the function u or u phi, which is equal to this. Solving this equation, we get the value of the function r, and we will just write the values. Similarly, solving this equation, we will get the value of the function t, that is t theta. Okay, t theta, and we will just write the values. And these things we have already done in third sem. Okay, what you do is that you just after this you just write the values of these functions. You say that solving this equation, we get the value of the function u, that is u phi. Okay, and value of u phi is this. Similarly, solving this equation, we get the value of the function t theta, and value is this. Solving this equation, we get the value of the function r, okay, and value is this. So from third sem, I think you have the class notes of third sem. So you just write the values. So after this, you just write whatever we did in third sem. All these things will be required, and these things are exactly same. So today I stop here. So after this, I once again repeat, after this you write what we have done in third sem. Okay, that means you write the values of these functions and see all those things which we did in third sem, you write. Okay, and after you write all these things, you let me know, and we will then proceed. Okay, so thank you then.